Hello everyone and welcome to my YouTube channel. My name's Pete and my aim for this is for it to become a series of videos documenting my electronics slash robotics slash 3D printing projects. I mean my working title is Project Starter because as people who know me very well will know, I am a serial project starter. I get some flash of inspiration and start making something, start programming something. I get a little way into it. I get the first prototype done, or maybe part way into the first prototype, and then I move on. What that means is I've bought a lot of components over the years. So I've got boxes of microcontrollers, motors, mechanical parts like gears and axles. I've got electronic components, discrete ones. I've got loads of stuff. I've got prototyping gear. I've got some test equipment. I've got an oscilloscope, and now I've got a 3D printer. So what I'm hoping is that now that I've got something that kind of lets me prototype mechanical parts easier, maybe with the help of the encouragement of a YouTube channel, that I might be able to actually keep going a project and see it through to the end. So the working title for this series is Project Starter, but I hope that kind of becomes a reference to the past rather than the reality of what it's like watching my videos. I don't have any specific projects lined up right now because I still have a couple more modifications I need to make to my 3D printer. And I'd like to go over those first. So this video is really just a quick introduction with a little bit on my 3D printer. So we'll start there. So this is my 3D printer. Some of you who don't really know much about 3D printers will be going, yeah, it's a 3D printer. Those of you who know a bit more about 3D printers will be going, what the actual hell is that? At its base, it's a G-Tech i3 Pro B, which is it's a Chinese clone of a Prusa Mark II, I think. The Prusa is a pretty well-known, well-loved printer. The official one that you can get, like the Mark III, is the popular one at the moment. They cost about £600, I think. And they, these parts here are all aluminium, very well made. You can put the kit together and have a working printer pretty much straight away. This one is made of acrylic instead, so it's got a bit more flex to it, which can lead to some problems with very fine details. But generally, it's okay. And that's generally what I would say about this printer. It's okay. But it took quite a long process of modifications to get to the stage where it's printing good. I wouldn't bother buying this one again if I had the time again. So I would, if I had the money now and I was off to buy myself my first printer, the one that's popular at the moment that everyone seems to say is great is the Creality Ender 3, which is only slightly more than I paid for this. And since then I've had to buy additional parts and I've spent a lot of time, so I'd go for something like that. Now I'd like to go into some of the changes I've made to this printer over the last couple of months. first change that I made was these screws. The ones that came with the printer were very low quality. They didn't move very smoothly, and one was it was bent so much that it actually was affecting the prints. So I got some nice new lead screws from Amazon. They're very, very nice. They kind of actually caused another problem that this printer had to get worse, which was on the original printer, these screws are turned by a motor here and a motor here. They turn and move the axis up and down, and they move at exactly the same time, so that the left and right side moved at the same time and kept level. Except I started having problems with one side moving more than the other, and also when the motors were off and it became freer, because of these smooth screws, you could actually push down on this side and it would turn the screw. So a lot of the time I'd turn the printer on and find that at some point something's moved and it's no longer level, and I have to level it each time I turned it on, which was just a nightmare. So I created this up here, so that both screws are belt driven from a single motor, and that means they are always moving in unison. They can't get out of step without taking the belt off. And yeah, I've not had a single problem with leveling since then. Another change I've made is to add on this spool holder. So it's got very little friction and it can pull the filament down with very little resistance. This is based off of ideas I've seen online, but I created this myself using OpenSCAD, which I might make a short video at some point sort of explaining how I created it, just because it is a very simple part. You can kind of see that these parts are joined on with a dovetail, so that if something breaks here I can just reprint this part, which is even smaller, and I can just replace it. Down here there is a Raspberry Pi which is running Octoprint. Octoprint is some software which allows your 3D printer to run off of a network interface. So it runs a server which you can connect to over Wi-Fi and send the print files directly to this, and then the Raspberry Pi computer actually manages the print from start to finish. So it sends G-code commands directly to the printer controller board. Oh yeah, also you can kind of tell this part, this is 3D printed. The original cable management that came with the kit was just some of this sort of wrap, and then the problem was the cables were the idea is you're supposed to loop it up over here and down, but it wasn't really long enough, and it was getting in the way, so I kind of routed it here using a cable chain, and yeah, that was quite an easy fix. And I kind of I joined these parts together. So this here is a touch sensor for measuring the position of the bed. This is a fan holder which I need to fix the fan because I broke it. I've got a new fan to put in there. So this is to blow air onto the part as it prints to stop it overheating. And so yeah, this was 3 parts that I fused together using Mesh Mixer and then printed as one object. Oh yeah, and I replaced the power supply. So this is just a standard ATX power supply. I think it's a 500 watt. The power supply that came with the kit was one I didn't really like the look of. It was it had the live wires almost exposed and right next to the power switch, so I just didn't like it. I thought I was eventually gonna electrocute myself or catch the place on fire, so I replaced it with something I trusted, and then and then I decided to chop all the wires off because the wires that come with this, it was like overflowing onto the floor. If you've ever seen an ATX power supply with all the cables attached. So I've just cut them down to minimal lengths, and this junction box is just the ones that I need. So I've got a let me see, the 3.5 volt supply, 5 volt, 12 volt, a ground. I think this is standby voltage, which is always on when the power is plugged in. This is the power switch, so this goes to the Raspberry Pi to turn it on, to turn the power supply on when the printer needs power. The grey one I'm not using, which is a standby, not standby, this is a voltage ready indicator, so you can put an LED in that and it will light up when the power supply is at the correct voltage, and then there's a separate ground, but not needed yet. Yeah, so the way it works is you just press this button and everything comes on. All the fans start spinning up and the display lights up. So this is the display for the 3D printer's control board. So this is nothing to do with Octoprint or the Raspberry Pi. This is just directly connected to this one over here. So this is for manual control. You can go in, you can change the settings in here, but you can do anything that you can do from here, you can do over the network using the Raspberry Pi. My next modification that I need to do is to do with this. So I printed this cute little octopus, and you can see it's got a pretty nasty layer shift here, and also if you look a bit closer you can see those shouldn't have those steps in them either. What this is caused by is when it's printing, the y-axis is controlled by this bed moving backwards and forwards. So relative to the nozzle, that's the way it draws in the y-axis. And however much I tune it, I always get problems with it missing steps now and then. So the stepper motors are told by the software to move, let's say, 1 millimeter, which corresponds to a certain number of steps of the stepper motor. And then because of the weight of the bed, maybe the motor doesn't quite get all of the steps done. It misses one, or maybe it goes too far. So it either gets, say, let's say that was 100 steps it needed to take, and it took 90 steps by mistake. The control board wouldn't know. The control board just sends the steps to the motors. If the motors don't make it correctly, then it will just carry on, and that's what's happened here. So it's I'm not sure which direction it went. I think this was the Y direction. I have had some steps missed on the X as well. So sometimes this is flying backwards and forwards, and it just goes a little bit too far or not quite enough, and then you get these little steps in the print. So what I'm going to do to fix that is I've bought these. So these are closed loop stepper motors. They take the step commands from the control board as usual, but they've got their own controllers built in and a sensor underneath which measures how much the motor has actually moved. So if this is told to take 100 steps and it ends up only doing 90, like I said, then it would know it only managed 90, and the controller would keep telling it to move a bit more until it gets to the 100. So it kind of slightly more complex than that, but not much. that's the essence of it. So basically this will know if it's not moving far enough, or if it moves too far, and it will adjust. Now they do just kind of drop in, so the one over on this side, this moves the x-axis when this, oops, I'm not looking. So when this turns, it moves the x-axis backwards and forwards. That just drops in. It's exactly the same. It's slightly longer, but it doesn't matter. It won't hit anything, and nothing gets in the way. But down there, that motor moves the y-axis, and as you can see, it's, well, you can't really see at the bottom, but it is flush to the baseboard, and it's flush to this back piece. And this motor has got cables coming out two sides, so I can't just put this in that gap. If I put it one way, these wires will be crushed against the bottom. If I put it the other way, they'll be crushed against the back. So I'm going to reprint the bracket that holds this motor on, and give it a little bit of extra space so that I can tuck these little wires behind the motor, or possibly the maybe this way round, with the control wires against the back, and then sort of feed it through. I'll go into more detail on the next video, because that's what I'm going to make an entire video about, modifying the brackets, printing it, installing it, and everything that goes with that. Well, I hope that wasn't too boring. I do have a tendency to sort of ramble when I go off script. It did end up a lot longer than I was expecting, but this is kind of an indication of what it's probably going to be like. I'm going to waffle on a bit. I'm going to do some projects. I'm going to explain roughly what I'm doing, and I'll try to go into as much detail as I can, and hopefully edit it into something that's actually enjoyable to watch, and hopefully give you some ideas yourself. Who knows where it's going to go. Like I said, the next episode is going to be focusing on the fitting those new stepper motors to the 3D printer. But after that, I've got some ideas for some things I would like to do. I've got to choose which one to go for first, work out what would actually work well as a small series. So it won't be one video per project, obviously. I'm gonna hopefully set up some kind of schedule. Maybe every week I'll do a video updating what I'm working on. That will probably vary depending on how much time I'm getting to actually work on the projects. But yeah, if you are interested to see what I'm going to do, maybe subscribe, like the video. I've got no idea if anybody's ever going to find this, to be honest. It might be that I only get like 10 views, which are, the few people I'm going to send this to. But we'll see. Bye for now.